The bonus topic today is NAT64 and DNS64. NAT64 is defined in RFC 6052 and RFC 6146. With IPv6 we don't have NAT anymore like we used to with IPv4. You probably know NAT because everybody runs it. In the beginning of IPv6 there was a bridging technology called NAT-PT, NAT Protocol Translation, but this was later removed again because people said we don't want NAT. NAT was a fix for something. We didn't have enough IP addresses, so we created it to share a single IP address to a whole network, but we don't want to bring that into IPv6. So NAT-PT was removed again. NAT64 is a translation between IPv6 and IPv4. If you have an IPv6 only network but want to connect to an IPv4 only server, like Dropbox. Dropbox unfortunately has somewhere in the protocol hard-coded IPv4 addresses, and if you have IPv6 only, then you cannot access Dropbox. You can use NAT64. For NAT64 you need routers. They must be dual stack, so they must have an IPv4 address and they also must have an IPv6 address. Remember, you connect using IPv6 to this router, and the router can send IPv4 packets to the destination that is IPv4 only. In conjunction with NAT64, there is DNS64. The DNS64 relay server intercepts DNS queries from clients and can respond with a quad A record even if the host only has an A record and only can do IPv4. In this case, the client would otherwise not be able to reach the IPv4 only server because it only has IPv6. Let's have a look how this works. At first, the client, which is IPv6 only, sends a DNS request for a quad A record of Dropbox.com. Number 2, the DNS64 server, which is a relay, can only find an IPv4 address for Dropbox.com, but it still creates a quad A record with a NAT64 prefix and the embedded IPv4 address. Number 3, the DNS64 server provides the client with a quad A record. So the client requested the quad A record for Dropbox.com and it receives a quad A record. And it does not know that there was an interceptor in between, the DNS64 server. So now that the client knows the IPv6 address of Dropbox.com, it can send the traffic to the router, which is NAT64 enabled, and the target prefix is the NAT64 prefix plus the IPv4 address. Number 5, the NAT64 server sees, oh, this address has the NAT64 prefix, so it's actually an IPv4 communication, or at least IPv4 destination. So it creates a mapping between the IPv4 and the IPv6 address, sends IPv4 packets out to the server, and once the reply is coming, it retranslates it into IPv6. So the client all the time just communicated with IPv6, and the server didn't even know that because it can only do IPv4. The NAT64 relay translates IPv6 to IPv4 and back, and the DNS64 server translates and intercepts DNS queries. If it can only receive an A record, it can still create a quad A record using this NAT64 prefix. It's a nice technology. In practice it also works, but you might still want to run dual stack. So thank you for attending. Remember, this was only an introductory course and we could not go into detail with all the topics, but stay tuned for more. Thanks a lot and have a good day.